So trigonometric functions are just standard integrals. So if you start with the differentiation, if you were given y is equals to cos x, if you differentiate y, what were you getting if you differentiate cos x? Negative sign, isn't it? Are we together? So it means when you integrate sine x, when you go back, you're supposed to get, if you differentiate cos x, you are getting negative sine x, isn't it? Meaning if you integrate negative sine x, you get cos x, isn't it? So it means when you integrate sine x, you get negative cos x. Because integrating negative sine x gives you cos x. So it means integrating sine x without the negative, you get negative cos x. Are you seeing that? Are we together? This is how it happens. If you differentiate y with respect to x, you get negative sine x, isn't it? So you take the x the other side of the equation, you get the y is negative sine x dx, isn't it? Then you introduce integral on both sides of the equation. So what do you see? If you integrate the y's, you remain with y. b goes with the integral, you remain with y, isn't it? So you have y is equals to the integral of negative sine x dx. So put the value of y. What is y? Y is cos x. Then so you multiply both sides by negative to get rid of negative here. You multiply both sides by negative 1, so this negative comes this side, isn't it? Are we together? Yes. So it means when you integrate sine x dx, you are supposed to get negative cos. Are you seeing that? You are supposed to get negative cos x. Is that okay? Are we together? You are supposed to get negative cos x plus c. So this is how it happens. When you are differentiating sine x, you are getting positive cos x. Are you seeing? But now when you are integrating sine x, you get negative cos, the sign changes. Differentiating sine x, you are getting cos x. But now when we integrate sine x, we are getting negative. So it means when we were differentiating cos x, what were we getting? Negative sine x, isn't it? Meaning when we are now integrating cos x, we now get negative, we now get positive sine. And this is how it comes about. So if you have y is equals to sine x, so it means differentiating y with respect to x. If you differentiate sine x, you get cos x, isn't it? Are we together? Then you take the x the other side of the equation, so you have the y is equals to cos x dx. Okay? If you introduce integral on both sides, you get y is equals to integral of cos x d. But what is y? Y is sine x. So it means when you integrate cos x, you're supposed to get sine x. Meaning when you have a sign, when you have a case where the sign was negative in differentiation, when it is integration, the sign changes to positive. Are we together? Yes. Good. So those two cases are enough. The rest did not have a negative sign. When you now want to list standard integrals. You now want to list standard integrals in trigonometric functions, isn't it? So you start. When you integrate cos x dx, what do you get? You get sin x plus the arbitrary integration constant, isn't it? Because when you differentiate cos x, you get negative sin x. So it means when you integrate cos x, you get positive. Are we together? Is that okay? Tuko pamoja? The sign only changes in the cases where you add the negatives, but other cases remains the same because there was no negative in other cases, isn't it? Then when you integrate sine x dx, you get negative cos x plus c. These are standard integrals, meaning that things you don't need to do, the things you know by default, isn't it? There are things you know by default, you don't do them, you just put the answer direct. Are we together? Are we together? Yes. Yeah. It's like somebody asking you 4 times 3 times 2. You don't need to tell us the steps for 4 times 3 times. You just write the answer 4 times 3 times, it is 24. What do you want to do there? It is a standard. Then if you integrate sec squared x, what do you get? Tan x plus c. Because you can remember, when you were differentiating tan x, you were getting sec squared x, isn't it? So it means now when you are integrating sec squared x, you are supposed to get tan x. Because in differentiation, when we differentiated tan x, we got sec squared x. So it means when we integrate this sec squared x, we are supposed to get back to where we were, isn't it? Are we together? Then when you integrate sec x tan x, you are supposed to get sec x, because you can remember in differentiation, when you were differentiating sec x, you got tan x sec x, isn't it? So it means now when you start from tan x sec x, what you got, you're supposed to go back to where you were, isn't it? So when you integrate sec x tan x, you're supposed to get sec x plus c, standard integral. Are we together? That is a standard integral. Yes. Good. So these are some of the cases you are going to meet in trigonometric functions, which are very important. When you are told to integrate, this one is also by default, sec x dx, sec x dx, you're supposed to get, if you integrate sec x dx, we are going to see how it is coming about. We're supposed to get ln of sec x plus tan x, then plus a arbitrary integration constant. We are going to see how that is coming about. So that is a standard integral. You don't need to do it when you see it in a question. Are we together? But we are going to see how ln of sec x plus tan x is coming about. But in an exam situation, it is not something to be done. It is a standard integral. Is that okay? It is a standard integral. It is a standard integral. So I sent for you